The other thing I said that you might be asked for in these problems sometimes is delta x. So what about delta x? Well, here's how we're going to figure out what delta x is. The average velocity is defined as delta x over delta t. And remember, we're being a little bit sloppy. We're going to follow the book and be sloppy and forget about the delta on the t here. The t is just going to stand for delta t. So that'll be delta x over t, as they wrote in the book. Now, what is the average velocity? Well, if you have a process where you have a final velocity and initial velocity, the average velocity is just the average of those two values. At least if the acceleration is constant, then the average velocity will be the average between the final and the initial. So the average of the final velocity and the initial velocity is Vf plus Vi. It's the sum of everything divided by the number of things you're adding. So the average here is you're adding up two values and you divide that by 2 to get the average. So the average velocity is the final velocity plus the initial velocity over 2. Now we've got an equation for delta x. That's kind of handy. I can write it out like this. If I multiply both sides of this thing by t, then I'll have t over t here on the left-hand side. That'll cancel out. And if I multiply the right-hand side by t, then I get Vf plus Vi over 2 times t. I'm putting these parentheses here to make sure I know that the t is multiplying all of this. Okay. That's good, that's handy. So if I know the initial and the final velocity, I know the time, then I can find out how far something traveled. Now there's one more equation which is real important, and that is, what if you don't know the final velocity? Let's see what we do then. Well, let's write it out like this. If I don't know the final velocity, I can always use this equation here to find the final velocity. So this is going to get a little messy, but we're going to go ahead and do it anyway. We're going to take this equation here, this expression for the final velocity, and drop it in there. We're going to see what happens. So let's just do that. Final velocity, instead of final velocity here, I'm going to put Vi plus At. I'm just going to write it in, Vi plus At, okay, instead of final velocity, plus Vi over 2 times t. This is what we call a substitution. I take this value here, this value here, Vf, sorry, I replace it and I'm substituting in this value here because I know that those two things are equivalent. They're equal. So I can always substitute something which is equal to for something else. Now what have I got? Vi plus At plus Vi over 2 times t. Let's see if we can simplify that. Vi plus Vi, what's Vi plus Vi? That is 2 times Vi over 2 plus At times t. Now I'm going to use the distributive property. I'm going to multiply t by these two pieces separately. So I'm going to write, first of all, I'll split these apart, because I know that 2Vi over 2 plus At over 2 is the same as this thing. The 2 over 2 here cancels, so I can rewrite that as Vi plus At over 2, over 2 times t. Now I'm going to keep going up here. This is all equation for delta x, so I haven't bothered to write delta x at every point, but let me write it here again just to be sure. Delta x. Now I'm going to use a distributive property, so I'm going to multiply Vi times t plus at times t over 2. So that'll be plus at times t over 2. And what do I get? vit plus at times t. What's t times t? That's t squared. at squared over 2. This is a very important equation when you're dealing with mechanics and physics. And this one you'll use in some of the more problems too. So if you know the acceleration and the initial velocity, you know the acceleration, the time, and the initial velocity, you can always get the change in position.